Good morning. In the previous lesson, I explained the types of waves, mechanical waves and electromagnetic waves. Mechanical waves may be travel or may be move by transverse wave or longitudinal waves, but electromagnetic waves move by transverse waves only. What is the difference between transverse wave and longitudinal waves? Transverse wave, this is the wave motion. It is the wave motion of the wave, in which particles of medium vibrate up and down, up and down, up and down. I mean the particles of medium, for example, water wave, transverse wave, like water wave. Water wave move up and down, up and down, up and down. So the particles of water move up and move down. Then transverse wave, it is the wave motion where the particles of water, the particles of medium vibrate perpendicular to the wave propagation, or the direction of wave propagation. In the sea, the wave come from inside the sea to the beach. This is the direction of wave. It's called the direction of propagation. Okay? Direction of propagation, this is the direction of propagation. Okay? And the particles of wave come up and down on this direction. So the particles of medium vibrate perpendicular to the direction, or perpendicular to the direction of wave propagation. Okay? But longitudinal waves, the wave motion also, or the wave of motion also, where the particles of medium compressed and rarefaction. So the particles of medium move in this direction. And this is the direction of wave propagation. Tuning fork produce wave, the wave move in this direction. So this direction is called direction of wave propagation. The longitudinal waves, particles of in the longitudinal waves, the particles of medium closed from each other and far from each other, and close again and far again. Okay? So this motion, the particles of medium in the same direction of wave propagation. Okay? Then transverse wave, again transverse wave, it is wave motion where the particles of medium perpendicular to the direction of wave propagation. And longitudinal waves, the particles of medium in the same direction of wave propagation. Longitudinal and transverse are method of motion, or method of motion of waves. Okay? For example, longitudinal waves like sound wave, like spring waves, but transverse wave like water wave, rope motion, okay, or string, or stretches string move up and down. When played by string, move the string move up and down. So this is wave is transverse wave, because the string perpendicular to the direction of propagation. Okay? The transverse wave consists of crest and trough. This is crest. maximum displacement in positive direction, or amplitude in positive direction is called crest. And this is trough. Trough is the maximum displacement or amplitude in negative direction. يبقى trough point which has maximum displacement in negative direction, but crest point which has maximum displacement in positive direction. Okay? And the distance between two successive crest and the crest, two successive crest and crest. This distance is called wavelength. It's called It's called wavelength. This is distance is called wavelength. Okay, wavelength or lambda, sample of wavelength lambda. The wavelength in transverse wave, this is distance between two successive crests or two successive trough. Wavelength, I mean the length of one wave here, up and down. This is one wave. Okay, remove this quarter and put this quarter instead of this quarter to make one wave. Quarter and a half and a quarter, one wave. The distance between two successive crests, this is the distance of one wave, I mean wavelength. So the wavelength is the distance between two successive crests, wavelength, distance between two successive crests or two successive trough. Okay, معايا يا شباب؟ طيب. But longitudinal waves consist of compression and rarefaction. Longitudinal waves consist of compression and rarefaction. This part is called compression and this part called rarefaction. Compression, rarefaction. When particles closed from each other is called compression, and when far from each other is called rarefaction. Compression and rarefaction. The distance between center of compression and the center of the successive compression, this distance is called wavelength, or center of rarefaction and the center of successive rarefaction is called wavelength. So the wavelength in longitudinal waves or of longitudinal waves is the distance between centers of two successive compression or rarefaction. Okay يا شباب؟ Okay. Then the wavelength, this is length. So it's unit centimeter or meter. Okay, equal wavelength equal distance over number of complete oscillation. I mean, this is if I has this distance, for example 20 meter، الاكس دي distance بالمتر، يبقى هنا لو البوينت دي ب 20 يبقى دي 20 متر، يبقى الويف لينث السامبل بتاعتها لامدا equal الديستنس 20 divide the number of complete oscillation up and down 1 up and down 2 up and down 3 يبقى 20 over 3 give the wavelength by meter. Why? Because the distance it's unit of meter. Okay, distance هنا اليونتس بتاعتها متر، لو سنتيمتر يبقى بالسنتيمتر and so on. يبقى ال wavelength هو distance over a number of complete oscillation. In general, the definition of wavelength, not for transverse or longitudinal, define wavelength only. Okay, wavelength or distance between 2 points in the same phase. Distance between 2 points having the same phase. Okay? What is the relation between frequency and wavelength and wave velocity? Velocity equal distance or speed, velocity or speed equal distance over time. Okay? Speed, distance over time, velocity, displacement over time. In this year, not important this difference. X over t. Wavelength, this is the distance. So we can put wavelength instead of x. And periodic time instead of time. So V equal wavelength divide periodic time. Since periodic time equal 1 over frequency, so V equal lambda over, instead of t هنحط 1 over frequency. Divide becomes time. So this frequency go up and velocity becomes equal wavelength and frequency multiply. Okay, يبقى new time lambda equal velocity. The unit of velocity meter per second. So must the wavelength unit is meter and the frequency hertz to give velocity by meter per second. If the wavelength given by centimeter, I can turn centimeter to meter. Centimeter times 10 of power negative 2 becomes meter. And when the wavelength given by angstrom, 1 angstrom equal 10 of power negative 10 meter. So multiply the number of angstrom times 10 of power negative 10 to change into meter. Thanks and goodbye.